So dear students, as per your request, I am hereby sharing the revision videos of your embedded system subject. So starting with the first unit which we are going to revise, that is the introduction to embedded system. In that we will see the embedded system, application areas, categories, overview of embedded system architecture, the specialities, recent trends, hardware architecture and the communication protocols. So whenever we are talking about embedded system, first we should know what is system. So system is a way of working, organizing or doing particular task. Whereas embedded system is a computing device which does its specific task, that is the VCD, DVD, we can say that. Means we can say that there are number of applications in our daily life, they are nothing but the embedded system. So it is a computing device which does its specific job. The appliances, as I said, at AC, VCD, DVD. Each of these appliances are having a processor and special hardware to meet the specific requirement of the application, along with the embedded system software which is executed by the processor for meeting the specific requirements. So embedded system is defined by various ways, like when Wolf said that uh, it is a device which includes programmable computer, whereas Todd Morton said that it contains the microprocessor and microcontroller, but we don't think of them as computers. David Simmons said that people use embedded system to mean any computer system hidden in the product. So we will see the basic important term. So the embedded system is a system which is combination of software and hardware or any other mechanical parts which makes the system dedicated for an application or specific part of an application or a product of or a part of larger system. Means in short, embedded system is nothing but the combination of hardware and software which is doing a specific task in a very reliable manner. That is the main definition of embedded system. Now we can say that it does its specific task. They can be programmed for different things. Embedded systems are having very limited resources. They have to work against the deadlines. The embedded systems are constrained for power. They need to be highly reliable. Embedded systems have to operate in extreme environmental conditions. Embedded systems addresses the consumer markets and application areas. Now we will see. So nearly 99% of the processors manufactured end up in the embedded system. The embedded system market is one of the highest growth areas as the systems are used in very market segment, that is the consumer electronics, office automation, transportation, military and so on. So talking about the consumer applications, at home we are using number of embedded systems like digital camera, digital diary, DVD player, electronic toys, TV, AC. Even today's high-tech car is having almost 20 embedded system for the transmission control and engine spark control. Even the wristwatches are now becoming embedded systems. The palm tops are powerful embedded systems using which we can carry out many general purpose tasks such as playing games and word processing and all. Then talking about the office automation. So the office automation products using embedded systems are the fax machines, telephones, modem, printers, scanners, etc. Then the industrial automations. So industries are using embedded system basically for the process control. That includes the pharmaceutical, cement, sugar, oil exploration, nuclear energy, electricity generation and transmission. The embedded systems for industrial use are designed to carry out the specific tasks such as monitoring the temperature, even monitoring the levels to control the devices. The robots are also now becoming very powerful and carry out many interesting and complicated tasks such as hardware assembly, which is a application of industrial automation as well. Then the next application area, that is the medical electronics. Almost every medical equipment in the hospital are nothing but the embedded system, that are nothing but the ECG, EEG, blood pressure measurement, endoscopy, everything, all that comes under the medical electronics. Because the development in medical electronics have paved the way for more accurate diagnosis of the diseases. Then the computer networking. So computer networking products such as bridge router, integrated service design, digital network, that is ISDN, Frame relay switches are nothing but the embedded system which implements the necessary data for the communication protocols. Then the telecommunications. In the field of telecommunications, the embedded systems can be categorized as subscriber terminals and the network equipments. If we are talking about the subscriber terminals, they are such as key telephone, ISDN phones, web cameras. Whereas the network equipment includes the multiplexers, packet assembler, deassembler, satellite modems. Then the wireless technologies. Advances in mobile communications are paving a way for many interesting applications by embedded systems. The mobile phone is one of the marvels of the last decade of 20th century. It is a powerful embedded system which provides voice communication when we are moving. Then comes the next, that is the instrumentation part. So, testing and measurement are the fundamental requirements in all scientific and engineering activities. The measuring equipment we use in laboratories to measure the parameters such as weight, temperature, pressure, humidity, voltage, current. Then, talking about security. Security of persons and information is always a major issue. We need to protect our homes and offices and also the information that we are transmitting and storing. So, developing the embedded system for security application is very necessary. So, we are having so many security devices not only at homes but offices, airports for the authentication and various verification purpose as well. Then talking about finance. So financial dealing through cash and checks are now slowly paving way for transaction using smart cards and ATM machines. Smart card of the size of credit card is having a small microcontroller and memory, and it interacts with the smart card reader or ATM machine, and it also acts as the electronic wallet. So these were the various applications of embedded system. Now the categories of embedded system, as its name implies, the standalone is there. Actually, total four are there: standalone, real-time, network information appliances, and mobile devices. So, as its name implies, standalone embedded system, it work in the standalone mode. Means it take input, process them, and produces the desired output. So that is the standalone system. For example, digital camera, microwave oven, CD player, and all. Then talking about the real-time system. So the embedded system in which some specific work has to be done in specific time period is called as real-time system. So there are basically two types: hard and soft real-time systems. Hard real-time systems are the systems where the deadlines are very strict, whereas the soft real-time systems, we can expect some millisecond delay which won't lead to a serious implication. So that is a hard real-time system. In soft real-time system, we can consider the DVD player, and in the hard real-time system, we can consider the aircraft as well. Then the network information appliances. So the embedded systems are provided with network interfaces and accessed by networks such as LAN or the internet, which are called as the network information appliances. Then the mobile devices. Mobile devices are the mobile phones, personal digital assistants, smartphones. That is the special categories of embedded system. These are the devices which moves with us. That's why they comes under the category of mobile devices. Then the overview of embedded system architecture. So every embedded system consists of custom built hardware built around a central processing unit. So the hardware also contains memory chips onto which the particular software is loaded. The software residing on the memory chip is called as a firmware. So we can see in the diagram, the embedded system architecture is represented by the layer structure. The operating system runs above the hardware and the application software runs above the operating system. The same architecture is applicable to any computer, including the desktop computer. So when we are talking about the various building blocks of hardware of embedded system, so there are basically that are CPU, memory, input output devices, communication interfaces, and application series specific circuitry. So CPU is we can say that it is a processor, and that can be any of following: microcontroller, microprocessor, or a digital signal processor. The microcontroller is a low cost processor microprocessor is more powerful, but we have to use the external components, and digital signal processor is mainly used when the signal processing is involved, like audio and video. Then the memory is categorized as RAM and ROM, that is random access memory and read only memory, so that is used. Then the input devices, they are nothing but taking particular input from the keyboard, through the keyboard or through the mouse for the interaction purpose. Then the output devices, these are the devices that are having very limited capability. We generally, the embedded systems are using few LEDs to indicate the status of the modules, that also comes under output devices. Then the communication interface, the embedded systems need to interact with other embedded systems or transmit the data. So to facilitate this, the embedded systems are provided with the communication interfaces such as RS-232, Universal Serial Bus and all. Then the application specific circuitry, that is the sensors, transducers, special processing and control circuitry are required for a particular embedded system. Then the specialities of embedded system, reliability. When we use desktop computers, sometimes they hangs and we use to reset it. Generally this does not cause any particular problem, but this is not the case in embedded system used in mission critical applications. There should be high reliability, so reliability is important in embedded system. The system should work at any cost in a proper way. Then the performance, many embedded systems are having the time constraints, like we have seen the hard and soft real time system. So for that, it is very necessary to have the performance proper for the deadline. Then the power consumption, most of the embedded systems operate through battery, so to reduce the battery drain and avoid the frequent recharging of battery, the power consumption should be very low. Cost, for embedded systems, the generally cost is very important. The embedded systems are using microcontroller and microprocessor, because of that the costs are also reducing. Size is a very important factor for embedded system. Generally we also don't like the things which are very bulky in size, so the size and weight are very important parameters. Generally they are very compact, that is the speciality of embedded system. Limited user interface, so unlike the desktop, which we have full-fledged input output devices, embedded system do not have the sophisticated interfaces, so they are having a limited user interfaces. Then the software upgradation capability, these are mean for a specific task, so once the software is transferred to the embedded system, the same software will run throughout the life. So it is always made available that the software upgradation facility is there, that's why the speciality of embedded system is that. Then the recent trends in embedded system, so most of the embedded systems are written in assembly language. So we will see now the recent trends that are available in the embedded system, that is the processor power. The growing importance of embedded systems can be caused by the availability of the processor. Now there are 150 varieties of the processors, like we can use 8-bit, 16-bit, 32-bit according to our need. Then the memory, the cost of memory chips are also reducing day by day, and as a result the embedded system can be made fully functional by using the additional features, because the cost of memory chips are becoming low day by day. Then the operating system, unlike the desktop on which the options for an operating system are limited, the main advantage of embedding an operating system is that the software development is very fast and maintenance of code is very much easy. Then the communication interfaces and network capability. With the availability of low-cost chips, the embedded systems can be provided networking capability through the communication interfaces. The programming languages, the development of embedded system was done mostly in assembly languages. Due to the availability of the cross compilers, most of the development is now done by the high level languages such as C. Even now the Java is also used many times. Then the development tools. So in the development tools, the availability of number of tools for development, debugging and testing, as well as for modeling the embedded system, is now a fast development of robust and reliable system. So the development tools such as MATLAB, Simulink are used to model the embedded system. Then the programmable hardware. So the PLD, that is a programmable logic devices, and the FPGA, that is a field programmable gate arrays, are used because they are reducing the components in the embedded system. Then this is actually exactly about the embedded system, and there are various communication protocols that are used like I2C, then the CAN. So CAN is a communication area network that we are using by using the CAN buses as well. So this is all about your embedded system revision unit 1. Now in the next video we will see the revision of our unit 2. Thank you.